True stress and engineering stress, the most commonly asked question. So how to define this engineering stress? We have represented this engineering stress with capital letter S. This engineering stress is also called your nominal stress. So engineering stress is defined as the ratio of the applied load to that of the original cross-sectional area. And what do you mean by this original cross-sectional area? It means the area which is before deformation. So before deformation has taken place, so what is that area? So that will be called as your original cross-sectional area. So here we have this, let's consider the area of cross section original, we have A naught. So if you divide this load to that of the original cross section area, that is S is equal to P by A, so this will be called as your engineering stress. And in the contrary of that, if you have this applied load divided by the actual cross-sectional area, which is instantaneous. So let us consider there is some deformation going on. So initially, let's say at time t is equal to t1, my original cross-sectional area of the body is a1. At time t is equal to t2, the cross-section got changed to a2. At time t is equal to t3, the area of cross-section got changed to a3. Okay, and the load remains same. Now here, if you want to find the true stress, so the general formula for the true stress is load divided by actual area. So here sigma at t is equal to t1, we can write load by what is the area at this time, at this instant we have a1. At this instant we have area a2, so this will be sigma at t2 will be load divided by area a2, and the load and the stress at t is equal to t3 will be load divided by a3. Okay, so this is basically your instantaneous thing. Now, what is the relation between your true stress and engineering stress? We know that the relation between the actual area to that of original area will be this. That is, actual area will be equal to A naught, either plus delta A or minus delta A, depending whether you are pulling it or pushing it. So now let us consider we have got a body which is subjected to tension. So in tension, you know that the body gets elongated. So in that case, the area of cross section reduces. So if your area of cross section reduces, then we can simply write AA is equal to A naught minus delta A. Now if area gets reduced, and we know that stress is lowered by area, so if actual area gets reduced, if the denominator gets reduced, what is going to happen to this term? Of course, this will increase, right? So since denominator is decreasing, the entire expression value will increase. So that is why we have written that in tension, your actual area is equal to A naught minus A delta A, and due to this, your true stress will be more than your nominal stress in this case. Now in compression, what is going to happen? Just the reverse of that. So let us consider we have got a body out here. Now if you are pushing it, so if you are pushing, so in that case, the area of cross section, that is actual area of cross section, will increase, as you can see from the figure. So we can write here AA is equal to A naught plus delta A. Now since the area is increasing, so overall value will decrease. So that is why we need to write here that is true stress will be less than your nominal stress. Now we have got a very important and very special relation which are generally frequently asked in your exam, that is sigma is equal to S into E plus 1, where sigma is your true stress and S is your engineering stress and E is your engineering strain. Make sure this is not true strain, rather it is engineering strain. So mug this relation up, because frequently they have asked so many times this direct formula or the numerical based on this. So sigma is equal to S into E plus 1. So whether you understand this or not doesn't matter at all, but you have to mug it up for scoring better. Okay, so since we have learned all this, that is true stress and true strain, true strain will be learning in the next lecture. So here we discussed about true stress and engineering stress. In the next lecture we'll talk about true strain and engineering strain. See you in the next lecture. Till then, bye.